Hello, welcome to the second lesson of Chapter 8. Today we're going to look at a composition of isometries. Now, composition of isometries, the composition of two transformations is the result of applying one transformation, then applying another transformation to the result of the first. So if I have a point, I can reflect it over this line, which would be up there. That would be P prime. And then I reflect it over the other line, which would be somewhere down here. So this second image is the is going to be P double prime, and it's going to be the reflection of the image of the very first one. So a composition of reflections over parallel lines. I want you to use your Mira mirrors and pause the video and see if you can work your way through this entire number one. All right, hopefully you're done. My drawing is not going to be as perfect because I don't have a nice mirror. So I'll just say this is about C prime, B prime is about here, and A prime is going to be somewhere in there. So I'm going to draw my triangle and label my A primes. Make sure you label all of these. Now when I reflect this, B prime is going to be here, A prime is going to be about there, and C prime is going to be about there, or C double prime. So now A double prime, B double prime, and C double prime. So if you did it correctly, it should look something like this. And if you did it much better than I did, it will look like this, your original triangle, is just translated over. So part C says the transformation from A, B, C to triangle A double prime, B double prime, C double prime is called a translation. Describe in your own words what the translation appears to do. And you can just say it shifts to the right, it slides to the right. Those are words that people typically use. Then it says what orientation is our double primes. And it looks like that's going around counterclockwise. And then it asks, what is the original? Does it have the same orientation? Yeah, that's also counterclockwise. So yeah. So why would that be? Well, a translation is just going to shift it over. That's not going to do anything with its orientation. Remember from yesterday, a reflection changes the orientation, but a translation now will not, or two reflections will not. All right, to the nearest tenth of the centimeter, we want to find the distance between M and N. And then I wanted you guys to go from A to A double prime. Now, your answers might be a little bit different, and I fully have faith that you guys know how to um, use a ruler. So, so hopefully you guys do that. Now we can answer I together. A translation is a composition of two reflections over parallel lines. The distance between the preimage and the image is, hopefully you figured out, was going to be twice the distance between the two parallel lines. Now this is a big idea, something good to highlight or just note off to the side. This is something that there's going to be questions on. All right, so now let's go to number 4 in your packet. We're going to start with DEF and we're going to reflect it over line P. So pause the video, do all of number 4 on your own, and then check to see if you're correct. Now I'm just going to do as good of a job as I can here. And then this one would be there. Something like this, where we have F, D primes E prime. And then down here, it's going to be D double prime, E double prime, and F double prime. So if this is our situation, now we can answer the questions. What's the orientation of DEF? That's counterclockwise. Counterclockwise. Does it have the same orientation as the first one? Yes. This is a rotation, and a rotation won't change orientation. What is the degree between the two lines? So I want you to find this degree measure using a protractor. And then it says measure from E to X, and then X to E double prime. And I want you to measure this angle. Now, they might be slightly off, give or take 1 or 2 degrees, but that will help us come up with our statement. A rotation is a composition of two reflections over intersecting lines. The number of degrees that the preimage is turned to arrive at the image is twice the distance or twice the acute angle that's between the two intersecting lines. So most people, I think, got this to be somewhere around 40 and this to be somewhere around 80 degrees. All right, with that, hopefully that's enough for you to start your homework. Good luck.